today we are going to be talking about linear and non-linear lines and how to discover. So let me go ahead and write that. So linear, there we go, linear equations is what we want to talk about first. And let's see if we can remember the characteristics of a linear equation. First of all, we know that linear equations are equations with a variable, equations that have a variable, with a power of 1. So we're going to think about that. So equations that have a variable with a power of 1. Now, linear equations can have more than one variable, but again, the variable with a power of 1. Now, the second characteristic is that the form most often used is y equals mx plus b. And that is our slope-intercept form. Now, if you remember, there are other variations of that form. We've learned the point-slope form, which was y minus y1 equals m times x minus x1. And then we also saw the standard form, ax plus by equals c. And both of those are variations of our slope-intercept form. Now, the third characteristic is that the line of the equation is straight. Is straight. Now, what I mean is if we have our graph here, and if I have a line, and let me just use a different color right here, you'll see a line like this with a positive slope, or you might see going the other way, a negative slope. So the line of the equation is straight. Now, we're going to be discovering some other things along the line as far as linear equations is concerned, but those are the three really main characteristics. Now, we want to do a little bit of a discovery to determine how to see if we can find out how to determine if an equation is going to be linear or not. So I'm going to bring up this app that we have not really used that much, but we will begin using, and that's called GeoGebra. Now, I'm in GeoGebra Classic, and I believe that if you have a Chromebook, this is also one of the apps on your Chromebook. And what we're going to use is the graphing part of it. And so when I go to perspectives, I'm going to have graphing hit or highlighted because I want to make sure that I have my coordinate plane here. So I'm going to put in a few equations. And as I put in these equations, we're going to determine if these equations are going to be linear or not. So the first equation I'm going to put in right here is y equals 2x plus 1. Now, if I put this equation in, you're going to see, well, that's linear, okay? Because right away I see that it is in that y slope-intercept form, 2x plus 1. The 2 is my slope. The 1 is, of course, my y-intercept. Okay, So we know that indeed is going to be linear. But let's look at another equation. And I'm going to put in y equals 2x squared plus 1. So I want you to think about that. And I want you to make a prediction. Do you think that that line will be linear or not? So go ahead and make your prediction. Okay, let's find out. So y equals 2x squared, notice what happened, plus 1. Now, I'm going to go ahead and I'm going to change the color. So I'm going to go to settings and I'm going to go to color and I'm just going to make that one red. I want you to be able to see the difference. Now look at here. Is that a linear line? Well, no, it's not. It's a parabola. It's curved. It is not a straight line. And so if I look at that equation, notice what happened. My x, my variable, is squared. Okay, it's squared. And so right away, that does not fit with the characteristics we talked about because that is a variable that is actually greater than 1. So that does not work. So you see two lines. One is linear, one is not. Okay, example number 3. Y equals negative x plus 1. Make your prediction. Do you think it will be linear or not? Well, let's find out. Y equals negative x plus 1. Well, okay, again, we see that it is indeed linear. And once again, I'm just going to change the color on this one because we want to see the different colors. So that one's going to be blue. Okay, once again, my line, y equals negative x plus 1, that is indeed in slope-intercept form. Okay, here is our next equation. Y equals 2x cubed plus 1. Okay, make your prediction. Do you think that will be linear or non-linear? Well, let's find out. Again, y equals 2x cubed. So I'm going to take this, let's see, and put a little 3 there. So hopefully, and again, let's see if I can get to my line here. Oops, I need to go back. Plus, forgot the 1, plus 1. So you see, now I have a different color, and that indeed is not a linear line. Now, we're not talking about if it's a function or not. I'm just checking if it is linear or not linear. We'll get into if it's a function later on. But you can see that these are not linear. They are not straight. Okay, let's do another example. Okay, our next example is y equals 4x minus 1. Make your prediction. Y equals 4x minus 1. Again, I want to change my color. And again, you see, and let's just put a different color so you can find that line a little easier. Let's put in a green. Okay, you can see, yes, that is a linear line. It's straight. My slope is 4. My y-intercept is -1. Now, let's try this. Y equals 4x to the -1 power. So, make a prediction. Do you think that will be linear or non-linear? 4x to the negative 1 power. Well, let's find out here. Y equals 4x to the negative 1 power. Oh, look at that. I get something totally different, don't I? And if I look at that, I see that is not linear. Again, it's not a straight line. I actually have looks like two half circles there. Okay, so you can see, based on the equation, what kind of line I'm going to get. Hey, we have a couple more examples. Here's another interesting one. Y equals 5 over x. 5, oops, see if I can slide this here. There we go. 5 equals 5 over x, or another way of saying it's 5 divided by x. Make your prediction. Do you think that will be linear or non-linear? Well, let's look. Y equals 5 divided by x. Oh, look at there. See my blue line? Now I'm going to make that just a little bit different color because I already have two blue lines there. So let me make this, let's make it a darker green. There we go. Okay, so again, you can see that that is not linear. Okay, so we had where the x was the denominator. Again, that's not the same form. Okay, here is one last example, and I want you to think about it. The equation is y equals 3x plus 2 squared. So make your prediction. Y equals 3x plus 2 squared. Do you think that will be linear or non-linear? Well, let's look. Y equals 3x plus 2 squared. Okay, notice now I have a power to the square. Now again, I want to just change my color here so that you can see. And let's make it a yellow. We haven't had yellow yet. Now look at that. It is linear. I had a power to the, a number to the second power, but notice it's not a variable that was raised to the second power. It was a constant, which I know 2 squared is the same as saying 4. So when I look at these different equations, different types of equations, you can see which ones are going to be linear or non-linear. Now, I want you to do a little practice, and I'm going to put a few little graphs or equations, and you're going to determine if they are going to be linear or non-linear. Good luck.